reduction to linear type. Okay, so this is y prime plus p of x y is g of x y a. Okay, this is definitely not linear, it's non-linear, so we have certain way to tackle this. All right, so the underlying philosophy is this. Okay, we want to make this nonlinear to linear, nonlinear in x, y, right? So because of this y term, it's nonlinear in x, y. We want to make it linear in x and u. Okay? If we able to make this equation is linear, right? Okay? By u is y to the 1 minus a. Okay? By using this transform, we want to have this equation, not the original one, okay? And then we solve in u, right? We solve in u because it's a linear, right? And then we go back to y. And then go back to y, right? Using this transform again. That's simple, that process. We are always doing that, right? Something that difficult, then we find the transform, right? And we went to the something that is easier, right? And then we solve it there, and then we come back, okay, to the original state. That's the whole process of reduction. All right. So let's look at how we are getting there. Okay. So we assume that u is y to the 1 minus a. Okay. That's the transform we try, and we do the differentiation. U prime is 1 minus a y to the minus 1, so it's minus a. Okay. But you don't forget y prime, because it's y. All right, then it's 1 minus a. Let's write this way. Equal 1 minus a. So y prime is here, right? Y prime is there. So we plug it in, y to the minus a. And y prime is g minus p, g. gya minus py. Okay? We simply plug it in, nothing special. And then u prime is 1 minus a and g minus p, you multiply and you factor out, then you get p y 1 minus a. Okay? You simply multiply, distributive, and then factor out. All right? No magic there. Then this is actually, what is it? So this one is u, right? That one is u. So you can eliminate y out of the equation, and you replace that y to u. Okay? So if you write it, plus 1 minus a, pu is 1 minus a, g. Okay? That's your linear equation in u. Okay? That's a linear equation in u. Linear in u. And what do you do next? You get f, right? And then solve and get, you get f, and you solve for u, right? And then once you get u, you use this relationship to get y. That's the whole process. All right, example 4. Logistic equation. This is that type of equation. Okay, logistic equation. We call it logistic equation, and that really represents the natural, phenomena on logistic things. So that's what it's named after. So you have y prime is ay minus by square. Okay, that's given. And if you write it in standard form, that should be minus ay equal minus by square. Correct? That's a standard form. Then you know that a, b are constant. Okay? It's just a number. So r meaning real numbers. Okay? Constant numbers. It's not function. All right? Anyway. And then your p is minus a, right? Your g is minus b. And your a is 2. Okay? You have to first identify the elements of the equation. And our, magic wand, which is minus 1, right? So that's our transform, to transform into solvable state. And you differentiate, u prime is minus y minus 2 y prime. Okay? From that, you don't memorize anything. You just do it, right? Once you know this, just memorize this. Okay? This one, you memorize, try to memorize it. But that's all. That's all there is. You just don't need to memorize anything at all. All right? So then, let's see. So, your objective is to eliminate y out of the equation, right? We don't want y in our equation. That's it, right? So, minus y minus 2 times y prime is here, right? So, ay minus by square, right? And then this is minus ay minus 1, right? You're just multiplying plus b. And we still have, y minus 1, okay? So we need to get rid of it by using this equation, right? So this is actually minus au plus b. Clear, right? And then you make it, linear in u. Okay? And you, the multiplication factor, right? So f u prime plus af u is bf, right? Since it's linear, you're applying the linear technique, right? And then let me see. Okay, so af equal f prime, right? So df over f is a dx. So f is e to the ax. All right. And then the rest is simply we are assuming e to the ax times u prime should be b times e to the x, e to the ax. All right. But then e to the ax times u is integration of b e to the ax plus, dx plus c. Okay, so u is b, so integration of this is b over a e to the ax plus c. Yeah, it doesn't really matter, but yeah, when I mixed up with integral factor, that means it really embeds at the end. Okay, so please correct me. If you if you can. So this is it. So u is b over a plus c times e to the minus ax. Okay? It's all embedded. The all, enduring factor will be embedded to the last one. Right? And the next is, since this is u, we simply use this one to get back to y. Right? u equal y to the minus 1. So u is y to the minus 1. So y to the minus 1 equal b over a plus c times e to the minus ax. And our y is one big, division. Okay?